Example 3, graph y equals the absolute value of x plus 2. Now an absolute value graph, let me just real quick get a clear piece of paper here. When you're looking at an absolute value function, what's inside the absolute value bars determines what values of x are important to you. Absolute value graphs do this. When you graph them, they do whatever they're going to do. When they hit the x-axis, they jump.
That looks good.
Maybe it does something like that. Now when you get a basic one like this, y equals the absolute value of x plus 2, what happens is it comes in a straight line. Oops. Comes in a straight line and then reflects off like that. It makes a V shape. All right? But depending on what's inside those absolute value bars, it can create any kind of shape, but it always has that. It comes down, it hits, and then it reflects. So it has that sharp turning thing happening. And those sharp turns happen whenever what's highlighted in green there is equal to 0. So the first thing I do in an absolute value function is I set what is inside the bars equal to 0. Whatever it is inside those bars, I set it equal to 0. And if I do that, that tells me what value of x I need to pick. And I want to pick numbers near that on either side of it. If that number happened to come out as a decimal or a fraction, pick whole numbers or integers around it. For example, if that came out to 1.5, pick 1 and 0 and 2 and 3. You don't have to pick 2.5, 3.5. Just go up to the next integer on either side of it and then go that way from that point forward. Or even if it was 1.25, pick 1 and 2 and 3 and 0. All right? Numbers on either side of it that are integers. All right? So negative 2 is the magic number here. I want to pick numbers that are less than negative 2, negative 3 and negative 4. Pick numbers greater than negative 2, negative 1 and 0. Once again, this expression is easy enough to evaluate on my own. Add 2 and then make it positive. What's negative 4 plus 2? Negative 2, then make it positive. Negative 3 plus 2? Then make it positive. Negative 2 plus 2? 0. Negative 1 plus 2? 1, keep it positive. 0 plus 2? 2, keep it positive. Okay, so if it's simple like that, again, you don't have to use a calculator.
So when
Go ahead.
you find x, it doesn't matter that there's absolute value bars? You find it at first?
Yeah, when you first find it, pretend the absolute value bars aren't there. Whatever's inside the bars equals 0 is your first step to figure out what values of x are important. That's where the turn is going to happen. All right, that's what you want to find on an absolute value graph. Now, in the event that you get an absolute value graph that's much uglier than that, you go to your y equals, you either go to math and go to the number tab. You got math, number, complex, probability, and fractions. Number tab, its very first thing is absolute value. A different way of getting to it is still, you want to be in y equals if you're graphing. Go to your catalog, it's under 0, so hit second, right there is catalog. All right, and the very first thing on the list is absolute value. When you enter that, it puts your absolute value bars. It's just looking for the insides of it, x plus 2. And then I'm still inside the bars. If I press to the right, now I'm outside the bars. So if I had to type extra stuff, that's how you get outside the bars. And then again, if I just come over here and enter my data in my table, my numbers are negative 4, negative 3, negative 2, negative 1, 0. It will evaluate those for me. Again, for this, hopefully you would be able to do it without doing that. But in this case, you know, just know that you can use your calculator to evaluate absolute value also. So negative 4, 2 is right there. Negative 3, 1. Negative 2, 0. Negative 1, 1. 0, 2. And notice it creates that V shape we were expecting. And then we just connect the dots with straight lines. It's straight lines because it's x to the first power. If it's x squared, it starts creating curvy lines. All right? If it was x squared, you might have 2 points where it equals 0, in which case, let's say it equals 0 at 2 and 6. We'll pick 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, then you get all those points, and the graph will probably come down, up, and like that. Make some shape like that. A parabola where the negative part flips up. That's all absolute values do, is the negative part flips up. These were negative, we made them positive, it flipped up. These were positive, stay positive, it stayed up. That's all absolute value bars will ever do to a graph.